Study identifies compounds that may improve treatment of opioid addiction. This was printed in Yale News, May 2nd, 2023, by Mallory Locklear. Searching for compounds with the therapeutic effects of ibogaine, but not its toxicity, researchers found two that ease depression and opioid withdrawal. Since the 1960s, the hallucinogenic drug ibogaine has piqued interest as a potential treatment for opioid addiction. Fueled by limited experimental evidence and anecdotal claims by those who claim they no longer felt a craving for opioids after taking ibogaine. But the drug comes with risks, including heart disorders and death. In a new study, Yale researchers identified two compounds that, in experiments with mice, were shown to be more biologically targeted than ibogaine, but, like the hallucinogen, ameliorated symptoms of depression, anxiety, and opioid withdrawal. The findings could inform future drug development and lead to more effective treatments for opioid addiction, researchers say. Ibogaine, a naturally occurring psychoactive found in the iboga plant, is known to bind to all sorts of target proteins in the body. This tendency, scientists say, contributes to the drug's side effects and makes it difficult to determine how its effects arise. One of its targets is a serotonin transporter, which is also where antidepressants like Prozac, Celexa, and Paxil act. The serotonin transporter is a protein that sits within the membrane of neurons in the brain. Its job is to move serotonin, a neurotransmitter that has been linked to depression, back to into the neuron that released it in order to limit its effect. Antidepressants block the transporter from doing this, allowing serotonin to remain in action for longer periods of time. Gary Rudnick, a professor emeritus of pharmacology at Yale School of Medicine and co-senior author of the new paper, first became interested in ibogaine because of its effect on the serotonin transporter. He compares the transporter to a shipping lock. Much like ships pass through a canal, serotonin molecules first enter one gate on the outside of the cell. Once inside the transporter, the first gate closes and the second gate opens, allowing the serotonin molecule to re-enter the cell. Most compounds that bind to the serotonin transporter, including antidepressants and recreational drugs like cocaine, stop the transporter's actions by keeping the outward gate open. But as Rudnick discovered in previous research, ibogaine blocks the transporter by keeping the inward gate open. After making this finding, Rudnick wondered if other compounds that act on the transporter in this same way, by stabilizing this internal gate, could have effects similar to ibogaine's. The idea was that if we could find compounds that bind like ibogaine, then we might be able to identify compounds that were more selective for the serotonin transporter and wouldn't have the side effects that ibogaine has. Working with researchers at the University of California, San Francisco, the University of North Carolina at Chapel Hill, Duke University, and the Medical University of Vienna, Rudnick and his colleagues identified two compounds that might fit that bill. Starting with a database of over 2 billion compounds, the researchers selected around 200 million, with properties they wanted, such as the ability to get into the brain. From there, they used a computer program to see if the molecules would bind to the serotonin transporter in its inward gate open state. 36 of the best candidates were synthesized and further tested, and the researchers selected the 2 that bound most strongly to the serotonin transporter. Ultimately, the 2 compounds didn't affect the transporter in the exact same way as ibogaine. They didn't have the same effect on the transporter's shape, but they still work differently than other known compounds, said Rudnick. They were also potent and very selective for the serotonin transporter. In mouse models of anxiety and depression, the researchers found that the 2 compounds worked just as well or better than the antidepressant fluoxetine, known by its brand name Prozac. They also tested the most potent compound on opioid withdrawal symptoms in mice, comparing its effect to the antidepressant paroxetine, also known as Paxil, which is used to treat withdrawal symptoms in humans. Looking at various behaviors associated with opioid withdrawal, paroxetine subdued 2 behaviors, jumping and rearing, while the tested compound subdued 3, jumping, forepaw shaking, and whole body shaking. Some people swear by ibogaine for treating addiction, but it isn't a very good drug with bad side effects, and it's not approved for use in the U.S., said Bryant Shuchet, a professor at the UCSF School of Pharmacy and co-senior author of the study. Our compounds mimic just one of ibogaine's many pharmacological effects and still replicate its most desirable effects in behavior, at least in mice. Going forward, Rudnick thinks these 2 compounds could be further explored as treatments themselves, or as starting points for drug development. Further, he says the methods used in the study could be used to identify compounds for other treatment targets. In terms of drug development, I think this approach is very promising. We've shown that you can take a well-known target and in a relatively short period of time come up with very selective novel inhibitors for it. As for these 2 compounds, while there are already many options available for treating depression, the opioid withdrawal effect was worth exploring further, Rudnick added. That would be a great idea to pursue in light of the opioid crisis.